Hello everyone. In this video, I am going to show you how to apply the BRINDA function. This function allows the user to adjust the micronutrient biomarkers. The first step you will need to do is open the BRINDA website. There is a tab called the BRINDA approach. Click it and scroll to find our package and select the arrow. This will bring you to a new page where you will need to download both the sample code and sample data. The sample code is on R file, while the sample data is in SAS format. After downloading both sample code and sample data, please open the R sample code in RStudio. Once you have RStudio open, the first step is to load the BRINDA function and sample data. To apply the BRINDA adjustment function and import sample data, packages called BRINDA and Heaven are required. So you must install these two packages using the install.packages function. To load the newly installed packages, use the library function. The BRINDA package already contains our internal sample data. To load it, run the data sample data line. In this tutorial, I'll be using sample data in the SAS format. To import the SAS data from your local file, you will need to specify the path and the file name after the read_SAS function. And here's a way to find the path name. So right-click the file and choose Get Info. The content after where is the path that we need. So copy both the path and the file name and paste them after read_SAS function. Run the code and the sample data will be imported. If you would like to apply the BRINDA adjustment method to the data in other formats, you will need to import the data by using other functions. For example, if the data is a data file in DTA format, the function called read_DTA is required. If the data is an SPSS file in SAV format, then the function called read__SAV is required. If the data is a file in CSV format, then the function called read.csv is required. One thing you will need to pay attention to when reading in a CSV file is the statement header needs to be specified as true. After loading the data, we can apply the BRINDA function. In the BRINDA function, the user needs to input the required informations. The first one is the dataset name. Here, you will need to enter the name of the dataset. So I entered sample_data here. The second one is to select at least one micronutrient biomarkers you would like to adjust. The 5 micronutrient biomarkers a user may adjust in the BRINDA package are retinol binding protein, serum retinol, serum ferritin, soluble transferrin receptor, and serum zinc. In the sample data, all 5 micronutrient markers are available, so I entered the variable names found in the sample data after each statement. Next, you must select at least one inflammation biomarkers, AGP or CRP. In the sample data, both CRP and AGP are available, but before entering the variable names, we need to check the units first. Here, we require CRP to be in the unit of milligrams per liter, and AGP to be in the unit of grams per liter. In the sample data, both CRP and AGP are in the correct units, so we can list the variable name in the statements. However, if the dataset you are using is in incorrect units, you must convert the variable to the required units. The next part is a population group. 4 population groups are women of reproductive age, preschool children, other, and manual. If the user specifies WRA or PSC in a population, then the AGP or CRP reference values are generated from external reference values. If the user specifies other as a population group, then the AGP or CRP reference values will be calculated internally using deciles. If the user specifies manual as a population group, then the user also needs to specify AGP or CRP reference values in the next 2 statements. Here, I assume the population in the sample data is preschool children, so I entered PSC here. The user also needs to specify the output format, simple or full. If the user specifies a simple output format, the output dataset will be the input dataset with the adjusted biomarkers. If the user specifies a full output format, the output dataset will be the input dataset with the adjusted biomarkers, as well as the parameters generated in the regression adjustment, such as correlation, coefficient, p-value, and standard error. In this demo, I have entered full as the output format. After having entered all required inputs, let's run the function and to see what will be generated in the output dataset. So run the code and go to the console, and we can see every step when applying the BRINDA R function. Firstly, the input information will be checked thoroughly. A brief summary information will be given, including the input dataset name, the existence of each biomarker, the user-specified population, and output format. Then, the second step will be the biomarker adjustment. According to the user-specified population, AGP and CRP reference values will be generated. Additionally, the BRINDA R function can show the adjustment method applied to each biomarker. For example, in this adjustment, retinol binding protein, retinol, serum ferritin, zinc are adjusted by both AGP and CRP, and soluble transferrin receptor is adjusted by AGP only. Now, the BRINDA adjustment process is finished. In the dataset output section, since I selected full as the output format, the R function will add adjusted biomarkers and their corresponding parameters generated in the regression analysis to the input dataset. Let's open the output dataset and have a look. The output dataset contains the original variables from the sample data, and the BRINDA output variables calculated based on the sample data and the required input. All new generated variables will have a label that begins with the BRINDA output variable. Now let's go back to the sample code to look at some other example scenarios. In the example 1.2, for preschool children population, only AGP is specified. In example 1.3, for preschool children, only CRP is specified. In example 2, women of reproductive age is selected in population. In example 3, other is selected in population. In example 4, menu and AGP or CRP reference values are specified. These different scenarios demonstrate different combinations of population and availability of AGP or CRP, which may change the reference value and adjustment method for each biomarker. Finally, to export the output dataset to a local file, we need to pick corresponding functions. To export it to a DTA file, the write_DTA function is required. To export it to a CSV file, the function write.csv is required. To export it to the SAV dataset, the function write_SAV is required. In these three functions, we need to specify the R dataset name at the first, and then the local path as well as the new file name. After running the code, the dataset will be exported to the corresponding path. Thank you for listening to this tutorial on how to use the BRINDA R package. I hope this tutorial is helpful. If you have any questions, please feel free to reach out to BRINDA team.